Hello everyone, this is Dr. Michael from MLR Institute of Technology. We are going to discuss the topic decoder from digital electronics and computer organization. We are going to see the introduction, its details and applications. First of all, this is the diagrammatic representation of a decoder. To understand this better, let us consider the case of a simple truth table. Like, suppose we have combinations 0 0, 0 1, 1 0, 1 1. Now let us take an example where by giving any of these sequence 4 possibilities, suppose you want to control 4 appliances. Maybe you will give input 0 0 to control, suppose, fan. 0 1 to control, say, tube light. 1 0 to control, say, TV. 1 1 maybe to control your AC. Some different electronic equipments you want to control by giving these signals. How can you do that? For that you need to make use of decoder. So, for suppose, say this is fan, say this is tube light, say this is AC, suppose something else, suppose washing machine, right? So, now let us take the corresponding outputs. Okay, let us take fan, tube light, AC, washing machine. You can represent this in any case. So, first case you have 1, remaining all zeros, only you are controlling fan. Next case you are only controlling tube light, so remaining all zeros. Third one, you are controlling only the AC, so here 1, remaining all places zeros. Last case you are only controlling the washing machine, remaining place we have zeros. Now, the circuit element which performs this operation, that is for this set of inputs, it generates this set of outputs. Such a circuit is your decoder. So, now here we have seen for the case of 2 inputs, we have 4 outputs. In general, for the case of n inputs, you have 2 power n outputs. You can check that for the case of 3 inputs, you will get 8 outputs. For the case of 4 inputs, we will get 16 outputs. Hence, this is the general way of representing for n inputs, you have 2 power n outputs for the case of a decoder. Okay, then binary decoders are the inverse of encoders. The input for encoder will be this, the output for the encoder will be what you have on the LHS. So, what process the decoder does, that reverse of that process the encoder does. To assign a unique output to each possible binary codes. So, why unique output? Because usually we only control one output. For one switch, you want one output. You don't want to switch on, say, tube light and fan together, right? You want individual controllability. Hence, we have this point. So, here we have an example for 4 inputs. We would have 2 power 4, 16 outputs. Now, let us discuss the decoder circuit diagram. This is the circuit diagram for the decoder Q0. Okay, so here this we can represent it in general as Q0, Q1, Q2, Q3. For your understanding, I have spoken in terms of fan, tube light, AC, washing machine. Now we are generalizing it. Here we are taking Q0, Q1, Q2, Q3 in place of fan, tube light, AC and washing machine. So, the expression for Q0, how can we get? See all the outputs. Where do we have 1? Okay, here we have 1. If the inputs are A and B, the expression of Q1 we can take as simply A bar and B bar. So, Q0 will be simply A bar and B bar. What about Q1? A is in its complement form, B is in its true form. So it will be A bar and then B. Q1 will be A bar B. Q1 will be A bar B. Next, what about Q2? Q2 will be A in its true form, B in its complementary form. So Q2 will be A into B bar. A into B bar. Last case, here in this case, last case, for this particular one, we have two ones, both A and B are in its true form. So what does it indicate? The expression for Q3 will be simply A into B, both the variables in the true form. A into B, both the variables in the true form. Identify that there are no bars here because both the variables are in their true form. So now that we got the expressions, all we have to do is we have to construct the circuit diagram. How we can do that? So multiplication A bar into B bar. To perform the multiplication, we need AND gate. A bar is complement of A. For that we need NOT gate. So A bar, B bar, two NOT gates. Okay, we have two NOT gates. And how many product terms? 4 product terms. So 4 AND gates. Now let us see how we can construct this circuit diagram. So what we can do, we can take dedicated lines here A, and then via the NOT gate, the output of NOT gate will always be A bar. So this entire line we will call it as A bar, and this entire line we will call it as A. Likewise, this entire line we will call it as B, and then this entire line we will call it as B bar. Now that we got our 4 lines A, B, A bar, B bar, the construction of Q0 is very simple. Take input from A bar and then B bar. For multiplication AND gate, that's how we get Q0. Likewise, Q1 is A bar into B. So A bar from here, B from here. Q2, A into B bar. So A from here, B bar from here. Q3, AB, both in the true form, so first 2 lines. That's it. That's how we get the circuit for the decoder. Now let us look at the applications. So, memory. Paired decoders are generally used to choose particular memory area from a variety of memory areas. Inside a memory chip, we don't want too many lines going in. See, actually what a decoder does is, it converts, in place of taking 16 input lines, it is enough you take only 4 input lines. Okay. So what it does is, it compresses the number of lines going into any logical block. If you want to control 16 outputs, it is enough you send 4 inputs. So the advantage that we get is, we don't need to have too many terminals going into the IC, integrated circuit. So what advantage it gives? It helps in easily managing the integrated circuit. So that is the advantage in terms of memory. Then control circuits. Parallel decoders are utilized in charge circuits to produce control signals for various tasks. I have given you the example of controlling TV, fan. Okay. So logically, some other maybe you are controlling an electromagnetic relay to switch on a fan. So those applications, again, decoders are useful. Also, they are useful to drive the displays. Again, similar case where fewer number of inputs to control many particular individual components of your display. Also, in address unraveling, parallel decoders are utilized in address disentangling circuits to create the chip select sign from a particular memory or fringe. So it's also useful for the case of address unraveling, where we can go for address disentangling circuits to create the chip select sign for particular memory. Okay, then digital correspondence. Two-fold decoders are utilized in advanced correspondence to unravel the computerized information got over the corresponding channel. So here again we might have used these general terms: decoded, encoded. You encode something and then you transmit it. You are not transmitting the original data. So in such a case, we could have some security advantages. So that we can have in terms of the address and then also in terms of transmitting the data. Not only that, error correction. Last case. How can we have that error correction? We know very well that simultaneously you are going to switch on only one element. Suppose if we have a 1 here, remaining cases we have zeros. Suppose due to any noise signal, any disturbance, we got a 1 here. Then we can identify, okay, something is wrong here. So decoders are also useful for error rectification. So these are some of the vast applications of decoders. We have seen introduction and we have seen decoders, we have seen its applications. That's all for today's lecture. Thank you.